Okay, Assalamualaikum dan salam sejahtera. So, nampak ke slide saya?
Nampak.
Okay. Assalamualaikum dan salam sejahtera. So, we continue our discussion on the tutorial for ideal flow. So, let's say we have tutorial 1 is shown here. So, velocity component of a fluid flow are given as this one. So using the fundamental definition of stream function, examine whether this velocity component represent a physical possible two-dimensional flow. So means that you need to check this velocity, these two velocity, whether it is can be represent a real two-dimensional flow or not. So and then B here, the velocity potential function for an incompressible two-dimensional flow is expressed as this one. So shows that the streamline and the potential line intersect orthogonally at the point of 2, 2. So means that you need to show whether it is intersect in 90 degrees or not. So we go for the first question. So from the continuity equation for polar coordinate, we know that this is the continuity equation for polar coordinate, because the question here, you see that we have element of r here and element of sine theta here. So means that the coordinate is polar coordinate. So we use continuity equation for polar coordinate. So here actually you are not not compulsory for you to derive the continuity equation from the basic diagram. It is okay for you just to use the final continuity equation that we learned previously. So and then what we do is we substitute the value of UR and U theta in this equation. So we found that it is not equal to 0. So means that is because the continuity equation is not equal to 0. So therefore the velocity component cannot represent physical possible two-dimensional flow, because the continuity equation is not fulfilled. And then let's say we have a potential velocity as shown, v is equal x square minus y square. And then we could derive the velocity components by using the Cauchy-Riemann equation. U is equal dv dx, and then we have 2x here. And then v equal dv dy, and it is equal to negative 2y. And then from here, I think you could refer to our previous tutorial. So from the value of u and v here, we could determine the value of psi. So we get the value of psi is 2xy. And then you just do this equation. You derive the psi here. So dy dx for psi. And then you multiply with dy dx for phi here. And then you will get the value of negative 1. So without substituting the value of 2, 2 here, you could prove that streamline means psi and potential line means the velocity potential is intersect orthogonally. So this is the way to prove the streamline here, psi, is actually intersect with phi. Okay, phi 1 and phi 2 here. This is psi 1 and psi 2 in 90 degrees. So we go for tutorial number 2 here. So the question is, what is a stream function? A stream function is given by the expression psi is equal to 2x cubed minus y cubed. determine the velocity at point P equal 31, and C, a source with a strength of 0.2 meter cube per second, meter cube per second meter, and vortex with strength 1 meter cube per second meter are located at the origin. Determine the equation for velocity potential and a stream function. So we have a velocity potential is phi and stream function is psi. So and then we need to calculate what is the velocity component if the location is x equal to 1 meter and y is equal to 0.5 meter. So this is actually showing you the coordinate. So and then you need to sketch the flow field. So the flow field here is actually one of our outcome from this topic. So means that you are capable, you are unable to draw a line to show the flow field. Later on I will tell you about how to draw a flow field and how to get full marks for flow field. So for stream function, I think you could read from your textbook. So the idea is actually stream function is showing the flow rate. Actually, it's showing the behavior of one molecule to flow along his to show the behavior of molecule flow along its stream path. Okay, so this is the layman term for the stream function. So and then for B. So for B here, psi is given as 2x cubed minus y cubed. So and then from Cauchy-Riemann equation, so we could calculate the value of component velocity u and v, and then we substitute the value of 31 according to the coordinate given from the question, and then we could determine u is minus 3 meter per second and v is minus negative 12 meter per second. So, and then we go for question C here. Okay, so we know that from the question, we are combining source and vortex, because in our notes, we don't have any notes about source and vortex. So in this question, I would like to show you what happened if you have certain element combined with other elements. So the first thing that you need to do is actually you just add all the parameters. So kalau diminta untuk awak menyelesaikan satu masalah yang tidak pernah dibincangkan di dalam kelas, rule of thumb ialah awak campurkan nilai stream function atau awak campurkan nilai phi. So that is the basic idea of this one. Okay, so for phi combination here, so we combine phi for source and phi for vortex, and I think you could refer from the previous notes. So we could write as phi for source is like this one, and phi for vortex is this one. So and then it is given from the question. Let's see the question. Okay, it is a source strength of 0.2, and the vortex strength is 1 meter cube here. So we substitute here. So Q here is the strength of source, and gamma is the strength of vortex. So we substitute, so we get the psi the phi combination. So and then we try to calculate the psi combination here. So it is the same. You just combine these two basic function. So we combine the size of source here and the psi, the stream function of vortex, and substitute the value here. So we get this term for psi combination. So in this question, it is clearly for need for us to determine the velocity potential and stream function, because the question asks us to derive what is velocity potential and stream function. Okay, normally if you want just to solve the problem, maybe it's only need to get the value of stream function only. So for this question, so the question asks us to calculate the psi combination and the phi combination. So let's say we have 0.1 and 0.5. So it is, this coordinate is actually taken from the question because it gives that x is equal to 1 and y is equal to 0.5 meters. So we rearrange the location here as Cartesian coordinate. So we write as x and y. So you could see from the question here, so we have x and we have y here. So and then from the psi combination, okay, we do the by using the Cauchy-Riemann equation, we could get the velocity component. So we could get u and we could get v. We substitute with this coordinate. So and then we could found that the velocity is 0.028 meter per second and v is negative 0.89 meter per second. So and then question number 3 is to sketch the stream function, to sketch the streamline. So here we have source. So source means you have one flow from one source here for one point and its flow in radial direction. So awak ada satu aliran di mana ia bergerak daripada satu titik dan ia bergerak pada arah jari. So awak boleh imagine yang ini. So and then awak ada vortex. So vortex mean rotation flow like this. So mean dia seolah-olah bergerak pada arah theta tetapi mengekalkan nilai r. Okay, so nilai jari masih lagi sama. So kalau ada dua, seperti inilah. Okay. So kenapa kita ambil arah lawan jam? Kerana selalunya vortex kita akan ambil arah lawan jam. Kerana kalau awak lihat dalam nota saya yang terdahulu, saya memberi nilai negatif untuk vortex. Oleh itu, di dalam keadaan ini, awak kena imagine sedikit berkenaan dengan apakah hasil stream function ataupun streamline yang terhasil. Awak pun boleh imagine sekiranya satu molekul keluar daripada origin, source di sini. So, dia nak pergi ke depan tetapi dia ada tolakan theta di situ. So, tolakan, dia naik ke depan, so ada tolak theta. So, dia bergerak lagi pada arah jari dan dia ditolak lagi. So, dia bergerak lagi pada arah jari. So, dia ditolak lagi. So, oleh itu, dia ada tendensi untuk create flow yang berbentuk curve seperti ini. Oleh itu, kita boleh melukis combination of source and vortex will create this kind of patterns. Jadi, awak kena buat dia bengkok sikit lah sebenarnya. Okay, kerana nak menunjukkan that is the influence of vortex. Okay. Di dalam penulisan streamline, awak kena berhati-hati kerana awak mudah untuk dapat markah dan awak mudah untuk hilang markah. Pertama, antara elemen yang ada ialah awak kena melukis anak panah. Kerana streamline dia menunjukkan arah aliran. Sekiranya awak hanya melukis macam gitu sahaja, so kita tidak akan boleh beri markah. Kerana kita tidak tahu awak berfikir aliran tersebut adalah menuju ke arah origin atau menjauhi origin. Okay, so awak kena letak anak panah. Kedua, sekiranya awak perlu untuk melukis stagnation point, contohnya awak ada half body Rankine dan sebagainya. So, awak perlu melukis dengan jelas. Ada pelajar menulis half body Rankine, dia tulis CP-CP kat sini, antara kena dengan tidak dan sebagainya. Oleh itu, tidak ada markah. Kerana awak kena jelas di mana stagnation point itu berlaku. Dan seterusnya, saya harap awak dapat faham bahawa psi combination adalah nilai, okay, contohnya kita baru belajar rotation, flow around cylinder. So psi combination sebenarnya adalah combination between certain parameter. So sekiranya kita combinekan doublet dan linear, kita mendapat psi combination, dan psi combination itu sebenarnya hanyalah untuk bentuk bulatan ini sahaja. Oleh itu awak kena melukis dengan betul. tandakan ini psi combination equal apa. Dan also tandakan apa nama tu, stagnation point dengan baik. Kemudian lukislah flow yang lain dengan baik berserta anak panah. So anak panah di sini kena ada dan seterusnya. Okay. Sama juga sekiranya awak ingin melukis kedudukan stagnation point seperti di dalam nota kita. So kita ada kedudukan di sini dan kedudukan di sini. Okay, diharapkan pelajar boleh melukis dengan baik. Mungkin tak kisah awak nak lukis macam gini pun boleh, nak lukis macam gini pun boleh. Okay, tetapi idea ni ialah ia mestilah pada bukaan yang sama. Maksud bukaan yang sama ialah ada ketika saya pernah mendapat jawapan pelajar melukis seperti ini, dia melukis satu di sini dan satu di sini. Okay, so yang ini pada kami tidak beri markah. Kerana awak tidak nampak bahawa bagaimana cara untuk mencari sin theta yang between antara pi dan 2 pi. Okay, so dia adalah berkenaan dengan bukaan yang sama. Okay, yang itu saya harap awak dapat faham kerana ia menunjukkan kefahaman awak. Okay. So ini seterusnya sekiranya kita membuat simulasi menggunakan pelbagai jenis software. So jadi kita dapat menunjukkan bahawa combination di antara source dan vortex sebenarnya adalah sama seperti ini. Okay. So jadi saya harap awak dapat imagine walaupun ia boleh dibuat melalui simulation tetapi di peringkat syllabus kita lebih kepada imajinasi pelajar untuk combination di antara beberapa basic elemen. Okay, kita pergi kepada tutorial nombor 3. A rotational cylinder with radius r in a uniform flow as shown in figure Q2. So this is figure Q2. Can be simulated as a combination of uniform flow, doublet and free vortex. The combination stream function is shown as here. So dalam soalan ini, dia beri awak satu nilai psi combination, tetapi seperti yang saya katakan, awak kena berhati-hati. Di dalam psi combination ini, kita dapati bahawa nilai vortex di sini tidak ada nilai A. Oleh itu, kita kata, kita kena do something supaya kita boleh dapat nilai A. Okay, antara cara mudah untuk menyelesaikan masalah ini ialah awak boleh sahaja terus menulis. Maksudnya awak nyatakan dengan jelas bahawa this combination of uniform flow, doublet and free vortex will give us rotating flow on a rotating cylinder. And psi combination for flow on rotating cylinder can be written as, so awak tulislah psi combination untuk rotating cylinder. Okay, that's the way cara untuk kita menjawab. Saya harap awak dapat boleh memberi penjelasan dan awak boleh meletakkan equation yang awak ingin guna. Dan seterusnya, from this information, we need to calculate the velocity component in radial and tangential direction. So coordinate of the stagnation point if gamma is 4 pi r and u is 5 meter per second. Sketch the flow field and show the stagnation points clearly, and sketch the flow field of the circulation if the circulation is 0. So we go for the question number 1. So here, as I said, this is the basic idea, because to get the rotating flow on rotating cylinder, so we need to merge the linear, the doublet here, and also the vortex, and finally we could use this term. So again, if you remember this term, you may use on the spot. Okay, so if not, you need to prove step by step. Okay, so this is the equation for flow around a rotating cylinder. And then we could calculate the velocity component by using the idea of Cauchy-Riemann equation. So we have a UR here, we have U theta here, and this is the term for UR and U theta. Okay, so and then coordinate of the stagnation point is gamma equal to 4 pi r and u equal to 5 meter per second. So when we do something or dealing with a stagnation point, so the advantage is the velocity is equal to 0. So and then for UR here, So for UR, so we equal it with 0. So we could get it is R is equal to A. So and then for U theta here, so if we equalize it with 0, so we could find that sine theta is actually equal to negative 1 over 5. So which is, it is 191.54 degree and 348.46 degree. So and then we need to sketch the flow field of the stagnation point. So we know that it is at this region. So what we do is, okay, first, please make sure that you know the rotation. So because it is not state clearly in this situation, so it is okay for us to assume that we use the basic or the common diagram. So means the vortex is rotate counterclockwise, and then the flow is come from right to left. Okay, we have here, and then I'm sorry, we have a cylinder here. So and then this is the origin, the center point, and then we know the location of stagnation point. So what you need to do is you need to draw the stagnation point first. So and then you just imagine that the linear flow, okay, normally we are drawing like this one. So because the cylinder here rotate with certain velocity, now the linear actually come from different angle because it is a little bit twisted by the rotating speed. Okay, so means that what you need to draw is something like this one. Okay, so means that from the linear here, so it come here, it curve a little bit, and then this is the stagnation point. So it goes like this, and then it will comes out like this one. Okay, so and then the next line is not hit on the surface, so it will become like this one. Okay, so and here, so we have here and here, and so it's okay. And then I hope you could have ideas, because curve di sini kita kata semakin lama semakin meluruskan arah. Kerana kalau yang di bawah ini kita kata mungkin dia akan bentuk macam itu, dan di bawah sekali dia akan menjadi straight line semula. Sama juga di atas, dia mungkin curve sikit, atas kurang curve, dan akhirnya dia akan straight line kembali. Okay, yang itu yang awak kena imagine lah. Okay. So jadi di sini first you need to draw the stagnation point clearly, and then please make sure that the location of stagnation point is actually will reflect the real location. So mean the real location means dalam keadaan ini mungkin kedudukan dia 191 tu di sini dan satu lagi di sini. So awak kena buat dalam keadaan angle yang sama. Jangan yang saya katakan tadi, mungkin awak melukis satu di sini atau satu di sini, ataupun awak dah tahu nilai angle tersebut yang kita buat pengiraan di sini. So tetapi masih lagi awak melukis satu di sini dan satu di sini. So walaupun kita kata region kawasan ini adalah region sin theta sama dengan -1, tetapi seolah-olah awak tidak alert dengan jawapan yang awak dapat. Seolah-olah jawapan yang awak dapat tidak memberi satu kefahaman atau tidak memberi info kepada awak. So jadi maknanya masih lagi tidak dapat markah. So and then seterusnya we need to sketch the flow field of the circulation if the circulation is 0. So if circulation is 0, so means that the situation is now back into flow around cylinder without rotating, without vortex. So jadi memadai untuk awak melukis bulat dan lukislah stagnation point pada 0 dan 180 darjah. Lukislah juga anak panah perjalanan streamline yang lain. Okay. Seeloknya sampai habis lah, jangan awak berhenti tengah-tengah. Okay.